Okay, good morning, everybody. Thank you so much for being here with us early. First session of the summit for me, I guess for all of you as well. So my name is Sundwall. I run the Open Data program at AWS. And I'm going to talk to you today about how we think about open data at AWS and some of the work that we've been doing to accelerate research on Earth observation data by making data openly available on AWS. And then Balaji is going to talk about the intersection of open data and machine learning. And throughout the session, you'll get an understanding of how this can be useful for any sort of military operation or any kind of humanitarian operation or anything where you need to have precise information and extremely timely information about what's on the ground. So one question I like to get out of the way all the time right off the bat is, why does AWS have an open data program? Why is open data important to us? And the short answer to that question is because it matters to our customers. So we have tens of thousands of customers in the public sector. These are governments, research institutions, nonprofit organizations, non-governmental organizations. A lot of these organizations are required either by law or simply by their mission to make data available. So they have some sort of need or requirement to make data openly accessible to the public or to research communities. And like I said, sometimes this is because of a law, sometimes it's just because it's their mission. So in the case of a lot of scientific agencies like NASA or NOAA or the European Space Agency, they invest a lot of money in producing high quality, really valuable data. They want to get a return on that in some way. They have this obligation to make data available to as many people as possible so they can derive insights from it. And so our role is to expand access to data. So what we focus on are ways, showing off ways that you can stage data for analysis in the cloud that will expand access to data, that make it easier for people to get. And a good way to explain this is just to put yourselves in the shoes of a researcher who has an idea of something they'd like to do, some sort of research they'd like to do, some sort of question they'd like to ask. But the answer to their question lies in, let's say, 100 terabytes of data. Before the cloud, if you wanted to work with 100 terabytes of data, you needed to buy 100 terabytes of storage infrastructure, storage space, and then you had to somehow copy 100 terabytes of data, right? If you're lucky, if you've got a pretty good broadband connection, you could download 100 terabytes of data in about 200 days, right? So a lot of people are never going to do that. They are instead going to think of something else to do, think of another project that they want to work on. And what we've found talking to a lot of our customers is there's a lot of latent research out there. What we call this research that exists in people's heads and ideas they'd like to try, but they're not doing because they can't get to the data. So one thing that we do in our program is we run a thing called the Public Data Sets program, where we collaborate with some of our customers on basically to discover new ways to stage data for analysis in the cloud and expand access to their data. And it's been really interesting to see. We host many petabytes of data through this program. Are we all right back there? We host many petabytes of data through this program, and it's been really great because it's allowed people to do research and build new applications and services that simply wouldn't be possible before, and without making this data available in this way. And if you want to find a lot of examples of these data sets, you can go to registry.opendata.aws, and you can find a list of data sets that are available for you to use on AWS right now. And a lot of those data sets you'll find in the listing. They also have links to demos and tutorials and things like that you can use with the data. I'm going to talk a little bit about some of the examples of this and why we do this in a minute. As soon as my slides come back up. Okay, there we go. So one of the reasons we think this is so important, we think that open data is important for the research community, and really for anybody who's trying to get value out of data, is this idea. It's called Joy's Law. And so Bill Joy was a guy. He was a co-founder of Sun Microsystems, and he said this in the context of open source software, which is that no matter who you are, most of the smartest people in the world work for someone else. And the idea there being that if you want to, if you have code that you're willing to open up with people, you can take advantage of all the smart people out there in the world, no matter who they are or where they work. And we believe that the same thing applies to data. If you want to get insights out of data, you should put it to work as much as possible, and the great way to put it to work as much as possible is to expand access to it as much as possible. And from our perspective, one of the most sort of critical things that's keeping people from working with data is merely data acquisition. Like I said before, if you want to work with 200 terabytes of data, or 100 terabytes of data, it's going to take you a long time just to get it. If you're employing data scientists, or if you have really smart analysts on your team, you don't want them spending a ton of their time just acquiring data or just preparing data for analysis. If the data is staged for analysis in the cloud, that's going to save you a ton of time, and it's going to allow you to pay the salaries of those really smart people who are in a very competitive labor market right now. You're going to be able to get a lot more for your money if they're not spending their time just downloading data. And so what ends up happening in the cloud is that the notion of data acquisition almost goes away, right? So you still have to transfer the data from wherever it's stored to wherever you're going to compute on it. But the beauty of making data available in a cloud environment is that instead of having to download the data before you work with it, instead of having to worry about having all that infrastructure to work with it, you can deploy whatever sort of compute resources you want just next to the data right where it is in the cloud. Okay? And it sounds very simplistic, you just have computers close to the data, but that makes a huge difference, especially when we're talking about big data. I think a lot of people, when they think about big data and the limitations of big data, they think in terms of the limitations of just computing power, just compute resources, cores, or memory, and things like that. One of the biggest bottlenecks is just data transfer. How are you going to move all this data from wherever it's residing to where it can be computed on? If you can shorten that transit, it has a huge impact, especially when you're talking about working with millions or more files. And we have a term that we use at Amazon a lot, and this is a great term. If you take anything from this presentation, I think a lot of people might want to take this one home. It's undifferentiated heavy lifting. And undifferentiated heavy lifting it's a term that we use a lot at Amazon that helps us focus our work and focus our product development. We are always trying to look at our customers, learn from our customers, and find out what are all the things that they have to do that's keeping them from doing what they actually want to do. They're keeping them from doing the things that actually differentiate them, what their actual mission is. And if you think of that in the context of AWS, you can see how we work on, thank you. So we work really hard on making sure that you don't have to worry about buying servers and putting them into racks and configuring them and securing them and cooling them and all these sorts of things. You never really have to worry about running out of storage space. From the perspective of the Open Data Program and what we try to promote throughout the community and help our customers do, we want to make sure that researchers don't have to do this undifferentiated heavy lifting that comes with acquiring data. And so the advantage of this is that when data is available in the cloud, you have a global community of AWS users. We've got millions of users all over the world that have building all sorts of tools that integrate with AWS. So there's a very, very large support network. This is a huge benefit of AWS, is just our user base that have answers to all of your questions you would ever have about AWS, and consultants you can hire and partners that you can work with. The other thing is that when data is available in the cloud, we're always adding new features and tools. And as we add these new features and tools, the data becomes easier to work with or cheaper to work with, or you're able to work with it in different ways. And all of this amounts to an ability to do research faster and to find insights from data much faster and at much lower cost. And really dramatically lower cost if you consider people who are working with very large volumes of data and would have to acquire it themselves and store it themselves without the cloud. So let's talk about some Earth observation data, because that's really what's most applicable here to this audience and for this session. So a few years ago, we started making Landsat data available on AWS. Landsat, for those of you who don't know, Landsat is an Earth-observing satellite that's managed by the US Geological Survey in collaboration with NASA. And Landsat, it's continually orbiting the planet, and it produces imagery of all land on Earth every 16 days. And it produces what's called multispectral data, or multispectral imagery. So this image that you're seeing here, this is Wellington, New Zealand, and this is a false color image that highlights vegetation, right? So there's a lot of healthy vegetation around Wellington, New Zealand, which is why it's all pink like this. So Landsat it's really great data. And we started talking to our customers and realized, a lot of them wanted to do stuff with Landsat, but they're having a hard time getting it. And so we started talking to them about, what was so hard about getting it, and what were the limitations for them. And what we found was that the traditional way of getting Landsat data assumed, naturally, because this is normal, this is the way sort of the world worked at the time, was that if you wanted Landsat data, you would go to USGS's site, and you would click around and you'd find the part of the planet that you wanted to look at and find the image that you wanted, and you'd download it. And you'd download that image and you'd get a gigabyte of data. And in that, you'd get a tar archive. So there's like one file that's about a gigabyte large, and you would have all the visible light that comes with Landsat data. So this is the red, green, and blue light that you could use to make a natural color image. It includes infrared light as well, infrared data and thermal data, some other things, some metadata as well. And we started talking to people, and we realized that almost all of them threw away 60 to 70% of the data that they got from that tar archive. So they download this tar archive, and the connection, sometimes is a little slow, depending on a variety of factors. And then they'd open up the tar archive and throw away a bunch of the data. And we talked to a lot of people, and we started doing the math, and we realized, there are tens of thousands of people who use Landsat data, and the data is really valuable. There's like a ton of time being wasted like everywhere, just downloading data. And we're like, okay, well, I think we can help with this. And so what we did, we started working with some of our customers, specifically at Planet Labs and Esri, that worked with us really closely on this, where we developed a pipeline where we bring every Landsat image that's produced, bring that to that tar archive down into AWS, unpack it. We use a service called AWS Lambda to basically open the tar archive, and then make the underlying data, the TIFF images, the imagery data, available in Amazon S3 individually. And there's a little more magic done on the data. The data isn't changed, but it's reconfigured in a way that makes it a little bit easier to work with. I'm not going to go into that right now, but what we did with that kind of kick-started a movement, a community-led effort to create a new standard called the Cloud Optimized GeoTIFF. And so there's this URL on the slide, cogeo.org. You can go there to learn about that if you're interested in this kind of thing. But it was fantastic. So the result of this was great because all these users suddenly could access all this Landsat data without having to download it themselves. They could interrogate the data without having to acquire a gigabyte of data at a time. And it enabled the development of really interesting new interfaces and services. And this is just one of them, but we really like this one because the guy who made this animated GIF for us, which looks great on slides. So we always show it off. What's going on here is that, so you've got a browser map, typical, what we call a slippy map in a browser. You can click and drag around. And what's happening here is he's interacting with the Landsat data that's in these GeoTIFFs in S3. It's cutting tiles out of those images that are friendly to be rendered in a map like this, and generating these false color visualizations as well, all in real time without running any servers. This is very significant because it's extremely inexpensive for him, right? All of the underlying data is stored through our public datasets program in an S3 bucket. In this instance, we're making it available there, but anybody could make data available in this way in S3. And what he's doing is deploying what's called AWS Lambda functions. So these are event-driven compute functions that are going and grabbing little parts of GeoTIFFs on the fly and rendering imagery out of them in your browser on the fly. It's really, really remarkable. And again, this is just one example of the things that we've seen people do with Landsat. If you go to the site I mentioned before, registry.opendata.aws, you can look up the Landsat entry on there, and you'll see a bunch of other demos and tutorials of stuff that people have done with this. The upshot of this, and again, this is one of the great things about open data on AWS, is that it allows people to basically cut out the acquisition, right? And I mentioned this before, just sort of in theory, the benefits of this, but this is a nice graph because it actually shows the impact on one individual researcher. What you're seeing here is he was doing vegetation analysis on Landsat data. And what's on this graph are about 90,000 points. So he's analyzing 90,000 points on the planet or Landsat scenes. And what you see on the left side, the ones that are sort of higher up on the y-axis, that's the old way of getting data. He was actually getting it from a place with pretty good bandwidth. He wasn't actually getting it from the original source. But still, downloading a gigabyte of data would take, it's something like between like 350, 475 seconds per scene just to get the data and to do the analysis. Once the data became available on AWS, that all dropped down to about 20 seconds per scene. And we did the math here. I think what's going on here, I said there are 90,000 points. I think there are about 20,000 done the old way. We did the math. We found out that if he'd done all 90,000 scenes the old way, it would have taken him 250 days longer to do this research. Okay? And you know, we're very happy that we saved him 250 days of his time, or that, you know, he didn't have to spend 250 days downloading the data, and that his employer didn't have to pay for 250 days of downloading data. So the benefits of this kind of thing are clear. You can learn a lot more about the Earth observation data sets that we have here, and I think, you know, the applications for any sort of military mission of Earth observation data is pretty obvious. We have elevation models, certainly applicable and useful. Satellite imagery. Most of the satellite imagery we have is publicly available and open, so it's quite coarse. So it's not the kind of stuff, it's not very, very high resolution. But we also have radar data for the United States. But we also have some other weather data and climate models that are global. And so there's a lot of data in there that's available for you all to work with now and to research with now and to experiment with. And then for those of you that are in academic institutions or who are researchers, if you have a crazy research idea and you have ideas of what you could do with the data that we're making available here, you can apply for credits of AWS resources to do that work. So if you need compute power to perform your research or try something crazy, you can, you know, there's a link to this from aws.amazon.com/earth, or you can just, you know, type it in, go straight to /research-credits and fill out the form there. And we'll check out your grant application. So with that, I'm going to hand it off to Balaji, and thank you for your time.
Thanks, Jed. Jed talked about the benefits of sharing data in the cloud, and when you share data as part of the Open Data program, you're extending the reach of that data to a larger and growing community of users. It could be individual developers, startups, enterprises. So you're making this data available for everyone to use and accelerate research in this field. And now let's see how we can take that one step further by using machine learning on open data to dramatically increase the effectiveness of your mission. So our primary mission as it relates to machine learning at AWS, it's similar to how we thought about AWS Cloud in general. So what we did as part of the cloud, we want to make sure every developers have access to the collection of services, the cost structure, scalability, and the compute power, which was previously available only to the largest of organizations. We're taking a similar approach to machine learning, and we want to democratize that for everyone to use. So as part of that mission, we want to put machine learning in the hands of every developer and data scientist out there. To enable that mission, we're investing across the 3 tiers of services. At the base, we have the frameworks and interfaces for doing machine learning and deep learning on AWS. On the middle tier, we have the managed platform layer, which focuses on making developers more efficient as they build, train, and deploy machine learning models. We're going to talk a lot about SageMaker as it pertains to open data today. And at the top layer of the stack, these are machine learning application services, a series of pre-trained application services that Amazon trains and builds and hosts. These are available for you to access via an API call. This could be use cases for computer vision, or natural language processing, or conversational interfaces, or speech and language services, and so forth. These are, you don't have to worry about building the model, training the model, and managing the model, and so forth. So we do that undifferentiated heavy lifting, so you can actually take advantage of these frameworks by calling a simple API as part of the application services. As you think about your developers consuming open data and beginning their machine learning journey, where should they be spending the most amount of their time? What you will find is that there are 3 major machine learning stages as part of the machine learning lifecycle. So they will have the need to build the model, train the model, tune those models, and deploy the model in production and operate on the outputs. So the barrier to entry for machine learning today is really high, particularly because most of the challenges are related to data wrangling. So what you will find is that most of the time you're actually trying to do this process of making the data ready to be able to do machine learning. So which involves selecting the right data for training, because that's your ground truth, because your training model is actually as good as the training data that you provide. And then adding missing values and doing normalization or data cleansing. Then you'll have to annotate the data and label the ground truth. And then you have to do the model selection, clustering, classification, and selection, and so forth. And then you have to choose the right algorithm to train the model and evaluate and deploy in production. Or anytime you want to make any changes, this process has to be started all over again. So you can understand why this is cumbersome and why the barrier to entry is relatively high today. To help with that challenge, we released Amazon SageMaker. It's part of our managed machine learning platform. It is 3 products and platforms combined in one. First, you have the managed hosted environment. You'll have access to pre-built notebooks based on the popular open source Jupyter framework. And also, the developers can access that pre-built notebook for their notebooking. You can use the pre-built notebooks, or you can import your own notebooks. So pretty open model to your mission needs. Secondly, we've taken the common algorithms that are available in the market that people are doing for machine learning. So we have 12 managed algorithms that we support as part of the platform. So this could be k-means for data segmentation, or factorization machines for building recommender systems, or anomaly detection for random cut forest, or time series forecasting using XGBoost. There are about 12 different managed algorithms that we provide out of the box as part of the build environment. So internally, we have segmented the SageMaker teams per algorithm. So we have individual teams working on these algorithms. And what we were able to do is to, because of that, we were able to crank up the performance of these algorithms up to 12 times faster than what you can find anywhere else. And you also have the option to import your own models. So let's say you already have a model that you built currently in your environment, and you can import that in SageMaker and take advantage of the managed machine learning process. So the second component of the SageMaker process is the training and hosting environment. So here, you select the data that you want to train on S3. You select the compute you want to run your training on. This could be the powerful P3 instances that are available in the market today. That's available part of the frameworks and services and the interfaces. And the service takes care of the provisioning, the management of the cluster, the drivers are pre-installed, the autoscaling is taken care of, and the EBS volumes are pre-configured. So the developers no longer have to focus on provisioning and maintaining the cluster. So oftentimes you see teams deploy, there are 2 teams deployed for this. One, there's a team that does the data science. The other team that does the managing and provisioning and updating the drivers and so forth. You have 2 teams deployed. So the second part of that, managing and provisioning, is taken care of by SageMaker. So you don't have to worry about that part, so your data scientists can optimize their time as they're building and training these models. So secondly, you will have the need to optimize those models that needs to be trained. In the past, developers had 2 options. First, the ability to determine the data set and the size of the data sets you're training against. The second, you have to tune the actual parameters that are involved in the machine learning and deep learning model. So this is the part of the actual tuning the parameters. To help with that, we released a functionality called hyperparameter optimization. It's called HPO, where we automate the second part, which is the tuning of the parameters. Because in reality, you're dealing with hundreds and thousands of lines of parameters that needs to be optimized. And even you're looking at sometimes millions of lines of parameters that needs to be optimized for a lot of the mission use cases. So what we do is we run a machine learning algorithm on top of your machine learning code. It's using machine learning to solve a machine learning problem, kind of really interesting that way. And it can determine the parameters that needs to be optimized to make your models run faster. So the developers have been freed up to focus on the proper data sets and the data size that needs to be trained against. This is a huge win for developers. So the third and final component of the managed hosted environment is the development and production of these models. So what you will find is that you have a one-click deployment to production, complete with autoscaling, and the service takes care of provisioning and management of the clusters. A lot of times you see data scientists build these models, and you have to build an automapper or some functionality to expose a RESTful endpoint so your applications can integrate. So in this case, SageMaker automatically exposes a RESTful endpoint where your applications can integrate that automatically. It also supports, as part of the deployment, it also supports A/B testing. So let's say if you want to direct 5% of your users to a specific model, you can do so using adjusting the weights using SageMaker, using endpoint configurations. So you can also fully encrypt your SageMaker environment and host within the VPC construct that you define. So SageMaker also provides metadata for training duration, hyperparameters, model, and data relationships, ultimately enable you to experiment quickly. When you're building mission use cases, these are very specific use cases that you're trying to build, so you want the ability to be able to experiment faster and deploy faster, so you can take advantage of the managed platform to be able to do so. And also, it supports the pay-as-you-go model. So anytime the training stops, we automatically stop the instances. So you pay per second by the second you're using. And you don't have to worry about, did I turn off my instance after my training or so forth? So it will automatically turn off those instances for you. So the core theme here is speed in all phases. So Jed talked about how he was able, using Landsat on AWS, they were able to save hundreds of days on using Landsat data. So the core theme is also, as you're taking that data and importing that and trying to do machine learning, you want to enable speed in all phases. You want to iterate faster. You want the developers to build faster, train faster. And by removing the undifferentiated heavy lifting, they would have to typically endure in order to be doing machine learning models running in production today. So developers can focus on iterate, and move faster and create value for your mission needs. So to summarize, the first component, you have the managed build environment and the collection and preparing of data faster, and pick up one of the SageMaker managed algorithms that are optimized for performance, and set up your training and automated deployment that way. We're seeing several customers taking advantage of SageMaker today. GE Healthcare is using SageMaker to revolutionize how healthcare is being delivered and enhance care for patients. And Grammarly has machine learning powered application that helps millions of customers write better when it comes to posts or documents or social media posts, so they can be clear, mistake-free, and impactful. The Grammarly is using TensorFlow. It's a common open source model from framework from Google, and they use that in combination with SageMaker in the cloud and also on the devices to help millions of customers write better. Dow Jones is one of the largest financial provider for business and financial news. They have integrated SageMaker as part of their products and services. Tinder, a popular dating app owned by Match Group, they use SageMaker in assisting millions of matches per day. And I would say in the US, we're seeing customers internationally taking advantage of SageMaker. One is QuickPad. It is the largest recipe sharing site out of Japan. So now that we've gained some understanding of how you can optimize your machine learning process, let's talk about how you can use these models and services on AWS and open data to accelerate your mission. First off, we have SpaceNet. SpaceNet is accelerating computer vision research on overhead imagery, which is really important because today, most of the research has been done on pictures taken by people and terrestrial camera. So SpaceNet is an online repository of high-resolution commercial images from satellite that is already labeled and training for your training data to use machine learning research. And that's hosted on the AWS public data set. So the availability of these images as part of the open data program is making this research possible. So you can think about like how you can optimize your undifferentiated heavy lifting as it pertains to data wrangling or making the data ready for machine learning. So you already have that data that is already labeled and annotated for you to start machine learning today. The SpaceNet data sets includes over 5,700 square kilometers of full resolution imagery and more than 520,000 vectors collected through from the Digital Globe Worldview 2 commercial satellite, and includes 8-band multispectral data. This data is publicly available to advance the development of algorithms to automatically extract geometric features, such as roads, building footprints, and points of interest using satellite imagery. Because the imagery is already available on AWS and labeled for training, you can easily connect and integrate with services like SageMaker to accelerate the effectiveness. So in addition to the open data set, SpaceNet also hosts a series of challenges to encourage the development of algorithms to automatically detect and extract features from satellite imagery. Today, the map features such as road, building footprints, and points of interest are primarily created through human annotation process. So you're actually sitting there looking at these images, drawing bounding boxes on these images to identify these interesting points as a training data set. These automated feature extraction from these high-resolution images will serve important mission use cases such as humanitarian disaster response, as we observed recently during the flooding in Bangladesh, and also during Hurricane Maria in Puerto Rico. What was critical is to create the land, to be able to create that road network to map the ground data so first responders at a site of disaster can have the efficient path to go do rescue missions. The machine learning models generated from these challenges are also publicly available, and it can be easily integrated with services. So next up, we have the National Intelligence Advanced Research Project Activity, IARPA, within the Office of Director of National Intelligence, ODNI, that focuses on research programs to tackle difficult challenges of the agencies and disciplines in the intelligence community. So this challenge has published more than 1 million points of interest from over 200 countries. Based on the satellite-specific metadata, the participants will generate an algorithm to classify buildings, facility, and the land use provided images. So next up, we have DIUX. It's a Defense Innovation Unit Experimental, and the National Geospatial Agency are releasing a new satellite data set to advance computer vision and develop new solutions for national security and disaster response. So DIUX XView did a challenge that focused on accelerating progress in 4 computer vision areas. Reducing mission minimum resolution for detection, improving learning efficiency, enabling discovery for more object classes, and improving detection for fine-grained classes. So what that really means is all these challenges, the machine learning models and the data sets that's already trained and annotated is already available publicly. So if you want to start from, you don't have to start from ground zero. So you can take advantage of some of the things that's already out there as part of the public data set program, and also part of these challenges, you have access to these applications. So thank you for your time. Please complete the survey and provide feedback to us. Enjoy the rest of the summit. And one last point, as we're kind of wrapping it up. So what you'll see is that these machine learning data sets are already available, and they're increasing the results in your mission. And so as you're building your mission use cases, you will know much more precisely on what's on the ground. So you can take advantage of some of these models and training data sets to accelerate your mission. So thank you.